All right, do I have everybody? Finally? Okay, y'all can hear me okay?
Yes, ma'am.
Okay, good. All righty, so let's go ahead and take a look at where we left off the other day. We were working on polynomials. We had a couple of pages of homework that we will check first. All righty. Lights off in here. Windows just a tad and see. It's a little chilly. Get a little bit of light and warm it up a little bit. All righty, so we had activities 3, page 292. So we'll go ahead and start with these. These were the ones where we needed to write them vertically and subtract. And we talked the best way to do this is to rewrite the problem by changing from subtraction to addition. I would change to addition, and now I'd have negative 6x squared minus 3x minus 1. And let me change my pen color to make it stand out a little bit better. So I'm going to add negative 6x squared minus 3x minus 1. So I end up with 2x squared plus 4x plus 3. Okay, so as I go through these, if you have any questions, if you missed it and you need me to explain it, let me know. On the next one again, I change to addition. That means I have negative 2x squared, positive 4x, negative 2. So plus negative 2x squared plus 4x minus 2. So I end up with 4x squared plus 3x plus 1. Nope, not plus 1, minus 1. And then the last one, change to addition, positive 2x squared, positive 5x, positive 6, plus 2x squared, plus 5x, plus 6. So I'm going to end up with 5x squared plus 2x plus 3. Any questions on any of those? All right, and our next page was activities 3, page 294. So page 294. We had 2 addition problems, 2 subtraction problems. So our addition problems, we have 5x squared plus 2x. My pen isn't wanting to write really well. Minus 3. 7x squared minus 4x minus 3. 5x squared minus 3x. Now this one, negative 2 plus a negative 3 is a negative 5. 2x plus 5x is 7x. Negative 3x plus a negative 2x, I forgot my squared, is negative 5x. And 2 plus a negative 3 is a negative 1. Okay, so those were my addition ones. Now I need to change my signs here. So I'm going to change to plus, minus, plus, plus. Okay, so also one of the things that you can do in that situation is just make that a plus. I'd have to add a minus there, but now I can make those pluses. So 4x squared plus a negative x squared is 3x squared. Negative 5x plus 2x is going to be negative 3x, and 2 plus 1 is 3, positive 3. Again, I'll change my signs by plus, minus, plus, plus. So now I have 4x squared plus 10x minus 3. And then the other two, add the opposite So I have 6x squared minus 3x squared is 3x squared. Negative 5x plus a negative 3x is negative 8x, and negative 2 plus a positive 3 is plus 1. Add the opposite. 7x plus a negative 2x is 5x squared. Negative 3x plus a positive 5x will be positive 2x. Negative 3 plus a positive 5 will be a positive 2. Any questions on any of those? So the main thing about when I am adding and subtracting polynomials is just to pay close attention to what my signs are, okay? Looking at my signs and just remembering that with subtraction, change to adding the opposite. And I don't just take the opposite of the number that is right after the parentheses. I have to do the opposite of every number inside the parentheses, or every single term that follows after the parentheses, okay? Now, we did talk the other day about multiplying, and remember with multiplication, we looked at the first number, we looked at the coefficient of each variable, and we multiplied coefficient by coefficient, so that's where we multiplied number by number. And then if I had a variable, and the variable was the same, then I would add the exponents, okay? So x times x is x to the second power. So I would say, I would take my exponent of my first x, which would be x to the first. I would add the exponents and end up with x to the second power, okay? And we talked about how if the variables are not the same, then I just list them in alphabetical order in the answer. So today we're going to be doing the opposite of multiplication, and we are going to be dividing. So it says, when dividing monomials, divide the coefficients to get the new coefficient and divide the variables to get the new variable. The following rules apply to all instances of dividing with variables. So right here is where we are. When dividing with like variables, subtract the exponents to get the new exponent. So remember, when we multiplied, we added the exponents. When we divide, we subtract the exponents. When dividing different variables, write the divisor in the denominator. So we have a fraction term there. We've talked about how fractions are examples of division problems. When I'm simplifying numbers and variables, it is easier to look at it as a fraction. It's easier to simplify that way. So that's going to be what we're doing. We'll be looking at them in the form of a fraction. List the variables in order from highest degree to lowest. So still, if I had x squared, I'm going to put that before x, and all of my variables go before my constant numbers. And then it just says list unlike variables in alphabetical order. Okay. So in this example, I have 2x squared divided by x. Okay. So if I think about 2x squared, remember my understood coefficient of x is going to be 1. So I've got 2 divided by 1. Okay, and 2 divided by 1 is going to be 2. All right. And then I look at x squared divided by x. This is where I think of x squared with my exponent of 2. But now I'm going to subtract my exponent of 1 from my other x, okay? So then they show us by stacking it like a fraction. And so they've got 2x squared in the numerator and x in the denominator. So again, and I guess that's just a typo in the book because they didn't have a 2 in front of that x, and it should have a 2. So here, this is like 2 over 1 is 2. Now, when I have x squared in the numerator and x in the denominator, I'm able just to cancel out that x, and then I reduce this exponent by 1. So since this was x to the first down here, I'm able to cancel x to the first out, but that means I have to subtract 1 from my variable, the exponent of the variable in the numerator. So then I'm left with 2x to the first power, and we've talked about how I don't even have to write that 1, so it's just 2x. And it says that notice that the coefficients were divided and the exponents were subtracted. So in this example, I've got 3x divided by 2y. So when I have 3x over 2y. Remember, I look to see what can I simplify with my coefficients first. Well, 3 over 2, there's nothing I can simplify there. Now, if it was 6x over 4y, notice both 6 and 4 are divisible by 2, so that would become 3 over 2. But since I can't reduce anything with 3 and 2, it just stays the way it is. And then I can't cancel anything with x and y because they're different variables. So I would just write my final answer like that. There's nothing else I can do to simplify. Okay, so let's go ahead and take a look at our classwork. So I'm going to go ahead and write these vertically. So let's rewrite our problems vertically. 6x cubed over 3x squared. Okay, so in this situation, I'm going to start with my 6 and my 3. What is 6 divided by 3? 2. Because 3 divided by 3 is 1. 6 divided by 3 is 2. So I can see that I can reduce those. And 2 over 1 is the same as 2. Now, notice that in my denominator, I have x squared, and in my numerator, I have x cubed. Remember, this is where I say x cubed minus 2. I take the top number, or my top exponent, which is a 3, and I subtract the bottom exponent, which is a 2. And 3 minus 2 is going to be x to the first. Now, since it is in the numerator, remember, I'm able to cancel out that x squared. This x cubed becomes x to the first. So now my final answer is just 2x. I cancel my coefficients, and then I subtract the variables of the exponents. So now let's look at what happens when I have 6xy squared divided by 3y squared. Okay, again, I see that I've got 6 and 3, so I know 3 divided by 3 is 1, 6 divided by 3 is 2, so I've canceled those. I have an x in the numerator and no x's in the denominator, so there's nothing I can do with that, so I just leave it, okay? Now, I have y squared in the numerator and y squared in the denominator. So when I look at this and I say, okay, that means I've got y to the second power minus 2, 2 minus 2 is 0. And we learned at the very beginning of the year that anything to the 0 power is equal to what? Does anybody remember? 1. Good. Yeah, anything to the 0 power is equal to 1. So that means I can cancel these out, and that's like having 1 over 1. Okay, so if my exponents are exactly the same, then I'm just able to totally cancel them out, and that would be the same as having 1 over 1. Okay, so now let's look at what I still have left. Notice my 6 became a 2. I still have an x in my numerator. Okay, so in my answer, I have 2x. Now notice in my denominator, I only have 1's left, and 1 times 1 is 1. So 2x over 1 is just equal to 2x. So because my y's had the same exponents, they totally canceled each other out. Okay, and so they became 1's, and I know that when I multiply by 1, it's just going to be whatever it was. So 1 divided by 1 is 1, so I don't even have to have that in my denominator. All right, so we're kind of building on the same problem. You know, we started out with 6x cubed divided by 3x squared, and we had 6xy squared divided by 3y squared. Now we have 6x squared y squared divided by 3xy squared. So let's go ahead and rewrite it vertically. 6x squared y squared divided by 3xy squared. Okay, so like we've done in the previous examples, we start with canceling the 6 and the 3. They're both divisible by 3, so that becomes 2 over 1. So I've canceled those first. Now I have x squared in the numerator and x to the first in the denominator. What is 2 minus 1? 1. So that means my x in the denominator cancels out. My x in the numerator goes to the first power. And I know x to the first power is just x. And we just learned in the previous example, if my exponents are the same, they just cancel. Okay, so again, all I have left is 2x. So each one of these problems that we just looked at all simplify to be 2x. So each one was 2x. I stack them like a fraction, numerator and denominator, and then I simplify. So let's go ahead and work through these. Okay, so activities 2. We're going to start with 2x to the 5th divided by x cubed. Okay, what number do I understand to be in front of x cubed? A 1. And what is 2 divided by 1? 2. Okay, now I have x to the 5th over x cubed. That means I'm going to say 5 minus 3 is 2. So my 3 cancels, my 5 becomes a 2. So I have 2x squared. I only have a 1 in my denominator left, so my answer is 2x squared. Let's look at the next one. 4x cubed divided by x. 4 divided by 1 is 4. Now I have x cubed minus, or divided by x to the first, so 3 minus 1 is 2. So my bottom x cancels. This one becomes a 2. So I have 4x squared. Look at the one below it. 15y to the 4th over 3y squared. What is 15 divided by 3? 5. I have y to the 4th in the numerator, y squared in the denominator. 4 minus 2 is going to be 2. So this y in the denominator cancels out. My y in the numerator becomes y squared. So my answer is going to be 5y squared. Look at the next one. 10y to the 5th divided by 2y squared. 10 divided by 2 is 5. Y to the 5th divided by y squared means I'm going to have 5 minus 2. My 2 is going to cancel, and my 5 becomes a 3. So now I have 5y cubed. And the last one in this row, 12y to the 7th over 3y cubed. What is 12 divided by 3? 4. Now I have y to the 7th divided by y cubed. I subtract my exponents. 7 minus 3 is 4. So that 7 reduces to a 4. My y in the denominator cancels. So I have 4y to the 4th. Okay. Middle column, we can see they're getting a little more complex. So I have 2x cubed y squared over x cubed. Okay, so there's nothing to divide 2 by, or 2 divided by 1 is just going to be 2. Now, x cubed divided by x cubed, we said that those can just cancel as 1. So those go away, and then there's nothing to reduce with y squared, so 2y squared. 4xy squared over 2x. 4 divided by 2 is 2. Now, notice I've got x to the first and x to the first, so those are going to cancel out. And all I have left is y squared. 15x squared y cubed over 5y squared. 15 divided by 5 is 3. I have x squared in my numerator, no x's in the denominator, so I just keep my x squared. There's nothing I can do with it. Y cubed divided by y squared. 3 minus 2 is 1, so this y cancels in the denominator. This one becomes a 1. So when I write it, I just write it as a y. 10x cubed y squared over 5y. 10 divided by 5 is 2. I have nothing to cancel with x cubed, so I just move it over to my answer. And then I have y squared and divided by y to the first, so 2 minus 1 is 1. That means my y in the denominator cancels, my exponent becomes 1 up here, so 2x cubed y. And then the last one in this row, 12x cubed y to the 4th divided by 4xy. 12 divided by 4 is 3. X cubed divided by x to the first. So my x to the first cancels. This one reduces by 1. So now I have x squared. And then y to the 4th divided by y to the first. My y's cancel, and this one reduces to a 3. So I have y cubed. All right, now I want you to do the last row. I want you to work on this last row, set them up vertically as a fraction, divide your coefficients, subtract the exponents to divide. Okay. Once you're finished, you can look up and check your answers. If you missed something, look to see why you missed it. And sorry, this is supposed to be a 2. It looks like a Z. Okay, so we just divided our numbers, subtracted the exponents when we divided like exponents. Okay, any questions on those? Now, one of the things I do want to do is let's take a look at this problem here. Okay, I'm going to look at this problem right here. Now, let's say that it was written in reverse order, and let's say it was 5x squared y squared divided by 15x to the fourth y squared. I would rewrite it as 5x squared y squared over 15x to the fourth y squared. I'm going to do the same exact things here, except for 15 cannot be divided by, 5 can't be divided by 15, so I would just cancel, and I would say, okay, 5 divided by 5 is 1, 15 divided by 5 is 3, so now I can see that I'm kind of flip-flopping my reduction. Now notice down here, if I had 2 minus 4, okay, 2 minus 4 is a negative 4. So what I would do is my 2's here would cancel. Now this one becomes x squared up here. Okay, I said 2 minus 4 is a negative 4. 2 minus 4 is a negative 2. And then my y's would still cancel here. So my y's would cancel. So now I would notice that, notice everything in my numerator canceled except for that number 1. So now I only have a 1 in my numerator, but in my denominator, I have 3x squared. So if it's the situation where everything in your numerator cancels, you can't just do away with the numerator, okay? Because my numerator is now 1. So when I have a fraction, 1 over 3x squared is very different than 3x squared over 1. The reason these go away is because anything over 1 or anything divided by 1 is itself. But if everything in the top cancels, then I still need that 1 to be in my numerator. I don't think any of the textbook examples have that, but I know that I've experienced some questions on some worksheets and things like that. So I just want you to be able to know that if everything in the numerator cancels, you just still write a 1 in the numerator. We just don't have to do that in the denominator. Okay. So now we've looked at adding polynomials, subtracting polynomials, multiplying polynomials, and dividing polynomials. Now we're going to look at when we multiply a polynomial by a monomial. So remember, we said prefix poly. We said that could be a constant, it could be a monomial, a binomial, a trinomial, or it could be any other polynomial that has 4 or more terms. But we do know a monomial means 1. So I know that I'm multiplying a multi-term expression by a single expression, okay? And so it says to multiply a polynomial by a monomial, use the distributive property and follow the rules for multiplying monomials for each term, okay? So the distributive property, remember we've talked about how when I see something outside of parentheses, I want to distribute that to each one inside parentheses, okay? So if I have to distribute a 5, remember my parentheses are telling me I'm multiplying. So this is 5 times 3x. So what is 5 times 3x? What's 5 times 3? 15. So 5 times 3x will be 15x. And then 5 times negative 2 is negative 10. So my answer there is 15x minus 10. I just distribute my number to each one in parentheses. Same thing here, 2x times 3x. Now this is where we have to think about when we learned about multiplying monomials. I said, okay, I'm going to multiply 2 times 3 first. That will be 6. But now I've got x times x. Remember, this is where I think about my exponents of 1. And when I multiply variables with exponents, I add the exponents. So this will be 6x squared. And then 2x times 4, and they're both positive, so I know it's going to be plus. 2x times 4 is 8x. So 2x times 3x plus 4 becomes 6x squared plus 8x. Let's look at the next one. Now the next one, I can see I've got a trinomial. So I have to multiply 2x times x squared. I have to multiply 2x times 2x. And I have to multiply 2x times a negative 3. So what is 2x times x squared? 2x times x squared is going to be what? What's 2 times 1? 2. What is x times x squared? Remember, I understand that my exponent of x is 1. So that means I add these exponents, and 1 plus 2 is what? 3. So 2x cubed. Now I have 2x times 2x. What is 2 times 2? 4. And x times x is x squared. 2x times negative 3. 2 times negative 3 is negative 6. And I'm just multiplying by x. So I have 2x cubed plus 4x squared minus 6x. Multiply the coefficients, add the exponents. Any questions on that so far? So I follow the same pattern as I did when I multiplied a monomial by a monomial. Multiply the coefficients. If there's the same variable, you add the exponents. So let's go ahead and look at activities 2. So I'm going to distribute 2. So 2 times 4x equals, what's 2 times 4x going to be? What's 2 times 4? 8. So 2 times 4x is 8x. And then 2 times 1 is 2, and it's positive, so I have 8x plus 2. Distribute 3 to each term inside parentheses. 3 times 2x is, what's 3 times 2x? 6x, and 3 times negative 2 is negative 6. 5 times 2x minus 1. I multiply 5 times 2x and 5 times negative 1. 5 times 2x is 10x. 5 times negative 1, negative 5. 2 times 4x plus 3. 2 times 4x is 8x. 2 times 3 is 6. 3 times 5x, 3 times negative 3. 3 times 5x is going to be 15x. 3 times negative 3 will be negative 9. Okay, I want you guys to go ahead and work on the last 2 columns. Go ahead and work on those now. You're going to distribute the term outside to each term inside. Okay, we'll go ahead and take a break and come back and check them.
Miss Jennifer, I have to leave to go to my softball game.
Yes, very good. I'm almost done putting the answers on here so you can check your work if you're finished, and then you can go.
Okay, thank you.
Have a great game. Good luck.
Thank you.
Bye.
Bye.
All righty. So go ahead, and if you haven't finished, finish up. If you have finished, check your answers. So just remember, whether you're multiplying by 2 terms or 3 terms, you're just multiplying the same number outside of parentheses by each term inside parentheses. Multiply numbers by numbers, like variables by like variables, and when we multiply variables, we add the exponents. Okay? Any questions on that? All right, so we've looked at what we do when we multiply one by another. Now we've looked at what happens if I'm multiplying a monomial by more than one term. And now we're going to look at dividing a polynomial by a monomial. Okay, so this is where I'm going to, again, I'm looking at dividing more than one term by the same term. So just like when we multiplied and we had to distribute those numbers, we started with what was outside and we multiplied it by what was in parentheses. Now this time we're going to take what's inside parentheses and divide it by what's outside parentheses. So what I like to do is go ahead and rewrite it as 6x squared over 3 minus 3x over 3. Okay, because I'm dividing both of my terms by the same number. Okay, so that's what they've done here, except for they drew it out vertically, horizontally, and I think it's easier to see when you write it vertically. But notice here, I've divided both of them by 3 because that's what I'm dividing by here. So I just separate my 2 terms and divide. Okay, so now I can see, just like when I was dividing, 3 divided by 3 is 1, 6 divided by 3 is 2, so I'm able to cancel that. 3 divided by 3 is just 1 and 1. So now I can see here, I've got 2x squared minus, now notice everything canceled here and all that I have left is this x. So I have 2x squared minus x is my final answer. Okay. Oh, whoops, I forgot to divide by my x, by 3x. Let me redo that. I was just dividing by regular old 3 instead of 3x. Let me rewrite that. 6x squared over 3x. Now, minus 3x divided by 3x. I thought something didn't look right, but that's what it was. So again, start with my coefficients. Now I have x squared divided by x. My x cancels, and this becomes x to the first. And then these two just cancel. 3x divided by 3x is 1. So now I have 2x to the first minus, now remember this is 1. So 2x minus 1 is my final answer there. Since 3x divided by 3x is 1, it doesn't just go away, okay? It just reduces to be a 1. So it's 2x minus 1. And it says alternately, polynomials may be written using long division. Okay, This method can be easy. It can make it easier to avoid mistakes, especially in long polynomials. So in this situation, it says, basically what I do here is I divide my first term divided by first term. So what I mean is I'm dividing 3x into 6x squared. And I said that 3x will go into 6x squared 2x times. So just like long division, when I divide, then I have to multiply. So then I have 2x times 3x is 6x squared. If I subtract 6x squared minus 6x squared, that's a 0. And then I can see that this is minus 3x, and I bring it down. Now this is a little more complicated. And then I say, hey, 3x will go into negative 3x, negative 1 time, and negative 1. So when I subtract that, that ends up being 0. So I get the same answer. It's a little more confusing right now. We'll look at it more next year in Algebra 1. We'll do long division with polynomials. Right now, probably the easiest way is just going to be writing them as fractions and simplifying. Okay? So that's what we're going to do in our classwork. We're going to practice this, rewriting it as 2 fractions. So this is where I'm going to divide 15x by 5, and I'm going to divide 10 by 5. Okay? Since I'm dividing both by 5, all I had to do was rewrite it like that. Now I can cancel 5 divided by 5 is 1. 15 divided by 5 is 3. I have nothing to cancel my x with. 5 divided by 5 is 1. 10 divided by 5 is 2. So since my denominators are just ones, I don't have to rewrite them. And I just write my answer as 3x minus 2. Okay, so I set it up to where I put my 5 underneath each one as a fraction and simplified. Let's look at the next one. 6x squared plus 8x all divided by 2. So I'm going to put divided by 2x here, divided by 2x here. Since I did that, that's what I'm going to do. So I'm dividing both terms by 2x. I'm going to cancel. 2 divided by 2 is 1. 6 divided by 2 is 3. Then I have x squared divided by x to the first. I subtract my exponents, so that means my numerator is going to become x to the first. My x and my denominator cancels. So now my denominator of my first term has just become 1. 8x divided by 2x. 2 divided by 2 is 1. 8 divided by 2 is 4. My x's here cancel. So I can see that my denominators here are both 1, so I don't even need to worry about those. So I've got 3x to the first power, or just 3x, plus all that I have left here is 4. So 3x plus 4. Any questions on how we're canceling or how we're doing this to be able to divide? Now we have 3 terms. We're dividing them all by 2x. So draw my line, divide by 2x. Divide by 2x, divide by 2x. 2 divided by 2. 2 divided by 2 is just 1. Okay, so I cancel those. X cubed divided by x. My x is going to cancel. X cubed becomes x squared. 4 divided by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. X squared divided by x. This one becomes x to the first. This one cancels out. And then negative 6x divided by 2x, or just 6x divided by 2x. 2 divided by 2 is 1. 6 divided by 2 is 3. My x's cancel. So now, when I look at this, all I have left is x squared over 1, so I don't even need to write that, plus 2x to the first, just 2x, minus 3. I was able to cancel all my denominators. They were all over 1, so I don't even have to write them. All right, so activities 2, we're going to practice with dividing. I want you to rewrite the problem and then solve. So I'm going to start with 8x over 2 plus 2 over 2. I've taken each term inside parentheses, put it in the numerator, and I've put my number that I'm dividing by has become the denominator of both. So I can see that 2 divided by 2 is 1, 8 divided by 2 is 4. I don't have any x's to cancel. And 2 divided by 2 is 1. So I have 4x plus 1. Let's go below that. 6x minus 6 divided by 3. 6x over 3 minus 6 over 3. On these, my 6's and 3 are going to cancel. So 3 divided by 3 is 1. 6 divided by 3 is 2. Can't cancel my x with anything. 3 divided by 3 is 1. 6 divided by 3 is 2. So now I've got 2x minus 2. 10x minus 5 divided by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So I'm left with 2x in my first one. 5 over 5 cancels to 1 over 1. So 2x minus 1. At any point that you're having trouble and you're not sure why we're doing what we're doing, please let me know. 8x plus 6 divided by 2. 8x divided by 2 plus 6 divided by 2. I'm going to cancel my 8 and 2. 2 cancels. 8 becomes 4. So I've got 4x. 2 divided by 2 is 1. 6 divided by 2 is 3. So I have 4x plus 3. And then 15x minus 9, dividing both by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. 3 divided by 3 is 1. 9 divided by 3 is 3. 5x minus 3. Let's go to the middle column. Now we're dealing with variables in our divisors. So I'm going to have 12x squared divided by 3x plus 3x divided by 3x. 3 divided by 3 is 1. 12 divided by 3 is 4. Now I've got x squared in the numerator, x in the denominator. My x cancels, and this becomes x to the first. 3x cancels with 3x, and that becomes 1 over 1. So I have 4x to the first power. So the key is when you mark things out, make sure you leave yourself enough room and make sure you can see what you still have left over. It's real easy to get it kind of crowded and not be able to see what you still have left. So in that first one, we have 4x left plus 1. Look below that. 4x squared over 2x minus 6x over 2x. 2 divided by 2 is 1. 4 divided by 2 is 2. X squared divided by x. This x cancels. This becomes x to the first. 2 divided by 2 is 1. 6 divided by 2 is 3. My x both cancel. So I have 2x to the first power, or just 2x, minus 3. Below that, 6x squared minus 12x, divide both by 3x. 3 divided by 3 is 1. 6 divided by 3 is 2. My x's are going to cancel, and this one reduces to an exponent of 1. 3 divided by 3 is 1. 12 divided by 3 is 4. And my x's cancel. So I'm left with 2x to the first, or just 2x, minus 4. 16 x squared minus 4x. Divide them both by 4x. 4 divided by 4 is 1. 16 divided by 4 is 4. X squared divided by x. My x down here cancels. This becomes x to the first. And I know 4x divided by 4x is 1 over 1. So I have 4x minus 1. And then the last one in this row. 15x squared minus 6x over 3x. Excuse me. So 3 divided by 3 is 1. 15 divided by 3 is 5. X squared divided by x. This x cancels. This becomes x to the first. 3 divided by 3 is 1. 6 divided by 3 is 2. But then my x's cancel. So I've got 5x to the first minus 2. Now I want you to work on the last column. We have 3 terms. And so I'll go ahead and start this one for you. You're going to have 12x cubed divided by 3x plus 6x squared divided by 3x minus 9x divided by 3x. Look at what you cancel. Go ahead and work this one. Let's see what you come up with. So I start with 12x cubed divided by 3x. We know 12 divided by 3 is 4. X cubed divided by x is going to be x to the second power. Plus 6x squared over 3x. 6 divided by 3 is 2. X squared divided by x is x. Minus 9 divided by 3 is 3. X divided by x is 1. So my answer is 4x squared plus 2x minus 3. Any questions on that? Six x cubed divided by 3x plus 3x squared divided by 3x minus 3x divided by 3x. Go ahead and work this one. All right, so what do you find 6x cubed divided by 3x is? 6 divided by 3 is 2. X cubed divided by x is x squared plus 3x squared divided by 3x. 3 divided by 3 is 1. X squared divided by x is x. Minus 3x divided by 3x. 3x divided by 3x is 1. So 2x squared plus x minus 1. Let's look at the next one. 4x cubed divided by 2x. Negative 6x squared divided by 2x. 8x divided by 2x. Go ahead and work that one. Okay, 4x cubed divided by 2x. 4 divided by 2 is 2. X cubed divided by x is x squared. Minus 6x squared divided by 2x. 6 divided by 2 is 3. X squared divided by x is x. Plus 8x divided by 2x. 8 divided by 2 is 4. X divided by x is 1. So 2x squared minus 3x plus 4. 12x cubed divided by 3x minus 6x squared divided by 3x plus 3x divided by 3x. Go ahead and work on that one. Okay, 12x cubed divided by 3x. 12 divided by 3 is 4. X cubed divided by x is x squared. Minus 6x squared divided by 3x. 6 divided by 3 is 2. X squared divided by x is x. Plus 3x divided by 3x is 1. There's our answer. All right, last one. 15. Get it where it's not quite so messy. 15x cubed plus 9x squared minus 6x, all being divided by 3x. Go ahead and work that one. All right, so 15x cubed divided by 3x. 15 divided by 3 is 5. X cubed divided by x is x squared. Plus 9x squared divided by 3x. 9 divided by 3 is 3. X squared divided by x is x. Minus 6x divided by 3x. 6 divided by 3 is 2. X divided by x is 1. So 5x squared plus 3x minus 2. Any questions on these? Okay, so we've looked at how to not only multiply a monomial by a binomial or a trinomial, and in that situation we had to distribute each term. And now we divided each trinomial or binomial by the same term, and so it's kind of like using reverse distributive property. You're having to divide every term by the term outside parentheses. Okay. So I think what I want to do So that's 3 sections today. Doing the dividing, the multiplying and dividing. And I hate to go too much further with doing 3 sections today. Let's see. I bet I don't have that with me, do I? Hang on a second. Let me see what I've got with me. Let me try to pull something up real quick and we'll practice a little bit more with these. That's one thing that I don't like about this book is I don't feel like it gives us enough practice. Let me see if I can. Nope, that's not what I wanted. Let's see. Give me just a minute to find what I'm looking for on the computer. Get these to open up. Just a minute. For some reason, my computer has been lagging so bad. What I'm going to do is I'm going to go to share screen. Stop share there. It's not open. Mhm. Well, I can't get it to open. I don't know what's going on with my computer. It has been struggling. Oh, there it comes. Well, it's got the tabs at the top, but it won't open the page. Oh my goodness. Finally. Okay. So we can see here that I've got, I can distribute. Okay. So, and probably what I'll do is, let's see, it's 2:08. Probably what I'll do is I'll print these out for us to practice with on Monday, to practice just a little bit more before we start multiplying binomials by each other. I want us to make sure we've got plenty of practice multiplying a polynomial by a monomial, just to make sure that we've got good practice with that. So what I'll do is I will, for those of you that'll be here on Monday, I'll print out these sheets for us to have Monday. I'll email them also, so we'll have them. And then the other thing is going to be dividing monomials. I'll send that one. That's not the one I was looking for. Let's see. It's this one. That one, this one. Because since I've got these pulled up on my computer, I don't have my stylus to write on them. Well, I get, well, no, because I couldn't, because it's shared on my computer, so I can't write on it on the screen because it's on my computer, not my iPad. So anyway, so what we'll do is we will look more on Monday. We will work some more on multiplying and dividing monomials, get used to what we do to the exponents when we multiply, what we do when we divide, and then we're going to take it a step further to where we're multiplying a binomial by a binomial. I think, Hunter, am I glitching out on you?
Sort of. But yeah. I can't see anything on the screen other than the page isn't responding.
Okay, yeah, let me try to. Let me stop share. Is it not? Oh, well, it's just not working for us today. So what we'll do is we'll go ahead and end there. On Monday, we will review these concepts, and then we will work on multiplying a binomial by a binomial. Okay, so no homework for Monday. I hope everybody has a great weekend. If you have questions, be sure to let me know. If not, I'll see you Monday.
Okay. Bye.
Okay, bye-bye.